Okay, I've had a couple questions about problem number 15 on review number 1. It's a trig proof. And looking at it, I would say that we probably want to go ahead and start with the left-hand side because we can actually use the angle addition rules there on the left-hand side. So cos, cos, sine, sine. Alpha, beta, cosine change. And again, cos, cos, sine, sine. Alpha, beta, and cosine change. Okay, now notice that we have difference of squares factored for we're multiplying conjugate pair. So we do get, when I do cosine x cosine y times cosine x cosine y, I get cosine squared x cosine squared y. Not cosine to the fourth because the angles are different. The middle terms do eliminate, and then a similar thing happens with the signs. I get negative because negative times positive, and I get sine squared x sine squared y. Okay, now it is a good idea to look and see what you're trying to get sometimes with proofs, well actually many times, so you have at least an idea of where you're trying to go. Now notice we have cosine squared x minus sine squared y, and I have cosine squared x and I have a sine squared y, which means I don't really need the cosine squared y, I don't really need the sine squared x. And so what can we do with those? Well, since they're squared, we have Pythagorean identities that we can substitute. And so let's go ahead and do that. We have cosine squared x times, okay, cosine squared y is 1 minus sine squared y. And the sine squared x, I can substitute that, and I can substitute 1 minus cosine squared x and times sine squared y. Now, I went ahead and wrote it exactly the way it looks, but probably it would be a good idea to put that sine squared y out in front. You don't have to, just be careful because we do have to distribute the negative and the sine squared. So I guess we could go ahead and do that all here in one step. But you know what? Actually, I think I'm going to stop right there and let you guys finish this problem.